lesson. So we're going to be talking about washers. In other words, we're going to be talking about basically hollowness inside of our discs or inside of whatever shape we're working with. For number one, go ahead and tell me in the chat what would be one expression that you could use to write this, to give me the area. So what could be one expression? Okay, so I'm gonna write down the one that I see. I see 24 minus basically pi 2 squared, which is 4, right? Or the area of the square minus the area of the circle. So either one's fine. Notice that this, the order matters. You cannot do the area of the circle minus the area of the square, because as you can see, the area of the square is larger than the circle. Now let's actually look at 2. So give me what you could use to represent the shaded region. What? So essentially what we have is the circle, the larger circle, minus the smaller circle, right? So the area of the larger circle, which is pi, and let's make this r squared, and then minus pi, and then the smaller circle squared, which if we simplify, this is going to be pi 4 squared minus pi 2 squared, right? So you're taking the area of the larger one and then you're subtracting from it the area of the smaller one. That's basically what's going on, right? So now the following, I want to ask you the following. So is the following statement true? Is pi parentheses r, capital R minus lowercase r squared the same as this? Tell me yes or no. Is this true? Yes or no? Are they equivalent? Come on, even if you don't know the answer, just guess. Just make a quick guess. Do you think that pi parentheses capital R minus lowercase r squared should be the same as if you distribute the power of 2 to the 2 that you have inside? Okay. I'm going to show you 2 ways to figure it out. What this is basically saying, it's as almost as if I were to write it in this form. So what I'm saying with statement number 3 is if this is equivalent, 4 minus 2 is the same as this. So let's figure it out. So there's going to be 16 pi minus 4 pi, and this one's going to be pi 2 square, right? And then there's going to be 12 pi. And this one gives me 4 pi. So is it the same? The answer is no. They are not the same. You cannot distribute an exponent to the things that you have inside it. That is not the same as squaring both of them. Now, I'm going to give you a separate analogy. Subtracting the radiuses and then squaring them is not the same as subtracting the area of the larger circle minus the smaller circle. Now, mathematically, proving this for all numbers, you can do the following. So this is going to be the same thing as pi r minus r, r minus r, and then whatever that's equal to, and it's going to be pi r squared minus 2r plus lowercase r squared, which is not equal to pi r squared minus pi lowercase squared. Okay, so you have an extra term here in the middle. All right, so again, please try to remember this. They are not equivalent. Trust me, you will see this very often in today's lesson. And I just want to make sure that I help you see why this is not true. So now, what is today's lesson? Today's lesson is actually known as the washer method. Washers, if you guys haven't seen them before, are basically the objects that go between a bolt and its, what do they call it? So I'll draw here. So you could have a bolt like this, right? And then in here, we usually put around it a washer. So something like this. And the reason why we put that washer is so that it doesn't go inside into our surface, whatever it is. For example, it could be wood. So if we put this washer so that the bolt stops at a certain place. So it has different uses. We also use it in planes so that we have the amount of force that is entering the plane is limited or non-existent. So there's different things that we can use it for. So now let's see what it differs. So here I gave you an example. This is going to be a disk. Normally the disk is completely filled in. So when they're asking you what is the volume of a disk, you're basically finding the volume of the whole thing. But for a washer, essentially what you're doing is you're getting the volume of the larger circle, and then you're taking away from it the smaller one, okay? So then it makes sense that the area of this shaded region is going to be pi r squared minus pi lowercase r squared, right? So you're subtracting the smaller circle from this big circle. And here I made a big note. And this is just what we talked about last time. I put this, I think 3 weeks ago. But this is a big note. A big no. You shouldn't be doing this. Do not ever think that you subtract the larger radius minus the smaller radius. So in other words, never ever do pi r squared minus lowercase r squared. So you should never ever do that. What you want to do is always do pi lowercase r squared minus pi lowercase r squared. So you're always subtracting from the larger one. So the larger disk minus the smaller disk gives you that emptiness inside it. So please always try to remember this. And then this is an example from the book. In the book, they give you this, which basically summarizes what a washer should look like and also how it looks from the front. So this is going to be an example. This is my capital R and this is my lowercase r. And as you guys can see, this is the area that is being rotated around. So enough of the talking. Let's actually do a problem so that we can see how this is being applied and how it's going to look. And I'll come back to this one. So let's go to problem number 1. Everybody, please go to problem number 1 on your assignment, which is A10. Let me know if it's opened on your Schoology. So can you guys see the assignment or no? I believe not, huh? Okay, so let me publish it. Okay, go ahead and reload it and then check again, please. So let's see, Schoology. Okay, so it should look something like this. Can you see it now? No problem, Ciclad. Okay, so these are the problems that we're going to be working with. I went ahead and copied it already here. So please go ahead and copy it on your paper. I'll give you about 30 seconds to copy this down. Okay, now that you have this, let's start with the first one. So y is equal to x squared plus 1. Y is equal to x plus 1. So that means that it's shifted up. So you go 1 to the side, 1 up, 2 to the side, and 4 up. So it should look something like this. And on this side, the same. Right. Okay, notice that the units that I'm using for the X are slightly bigger than the ones that I'm using for the Y. So this is not to scale, but I just want to make a big picture so that you guys can see it on your screen. So I did the first one, X squared plus 1. Let's do Y equal to 0. So Y equal to 0 is going to be my X axis. So this is Y equal to 0. The next one is X equal to 0. So that's going to be this. X equal to 0. Okay, so we did this one. And the last one is X equal to 2. So X equal to 2 is the last one. And that is this. All right, so X equal to 2. Okay, so far, does anybody have any questions on the graph? Okay. And also let me know if I'm going too fast. If you want me to slow down, please let me know. Okay, so what we're missing is the axis of rotation, which is Y equal to -2. And for today, I'm gonna use purple for that. Oh no, that's very, very ugly. So let me try that again. Oh no. Sorry, I'm having difficulty drawing my line. Okay, there we go. So this is Y equal to -2. All right. Okay, this is the part where a lot of students are gonna get lost. And I feel that this is the part that I've seen most students not understand. What is it that's being rotated? Okay, so what is it being rotated? Try to think about it. Are we rotating 1, 2, 3, or 4? Or are we rotating a combination? So we can rotate 2 and 4, 1 and 3. Are we only rotating 2? Are we only rotating 1? What are we rotating? Interesting. So the answer is 2. We're rotating only 2. And I'll tell you one way that you can figure it out. You always decide what you're rotating prior to drawing your axis, okay? Or prior to seeing your axis. So that's why I went ahead and put my axis or rotation in different color. So I'll go ahead and erase it and you'll see. So what is it that is being rotated? If I ask you without the axis or rotation, you'll notice that the only thing that is bounded is this part number 2. So part number 2 is the only thing that's being rotated because it's the only thing that is being bounded. Part number 1 is not bounded. Part number 3 is not bounded. Part number 4 is not bounded. The only thing that is bounded is part number 2. What makes it hard is because I went ahead and drew the axis of rotation before determining it. But so if you are finding difficulty determining what you need to rotate, do your axis of rotation last. So do your axis of rotation last. Usually that's going to help. So what I'm rotating is this part. All right, so I'm rotating that part and I'm rotating it on this axis. So that means that the first thing I should do is reflect my, reflect the thing that I'm rotating. So I'm going to actually erase this part since I don't need it. And I'll rotate this part. So first of all, I have this. And then here it's how many units away from my axis of rotation. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So here. So it should look something like this. And it starts here. All right. Okay, so far, is there anyone who's confused on what I'm rotating and what I have? Okay, I don't see any questions, so let's continue. Let's go ahead and now make our washer. Okay, so we're making two discs. The one on the inside is going to be hollow, and the one on the outside, that one's going to be filled in, right? That's the one that we're keeping in a way that you can think of. So it's something like this. Let me try it again. So I'm trying to make it a little bit bigger than usual. Okay, so this is my outside disc. Okay. So that is my outside disc. So let's try to find the radius for that. So the radius, if you guys remember, it's from the axis of rotation to the function. So that's going to be this, from the axis of rotation to the function, and we're going to call that capital R. On the chat, please give me what is R. Okay, so what is R? In terms of f of x, this is f of x. Give me R in terms of f of x. Come on, guys, more of you try. What is R, capital R, in terms of f of x? So I see a lot of correct answers, so I'm going to write it here. F of x plus 2, because remember, f of x is the distance from the x-axis to my function. So that's going to be f of x, but that's not R. R is bigger than that. We are always adding 2 to my f of x to get my R. So that's why we do f of x plus 2. So that means that my R is going to simplify 2. My f of x is x squared plus 1, and then plus 2. So finally, my capital R is equal to x squared plus 3. Okay, is there anyone who would like me to explain something from how did I get my capital R? Again, my capital R is f of x plus 2, because the distance from the purple line to my x-axis is 2, and then the distance from my x-axis to the function is f of x. Okay, now here comes the part. We're gonna go ahead and take away from this, we're gonna take away from this disk, the inside. So I wanna go ahead and take away this. So I'm taking that disk on the inside. All right, I'm taking away the disk on the inside. I wanna make that hollow. Okay, I want to make the inside hollow. So I need to find my lowercase r. So this is going to be my lowercase r. So what is my lowercase r? What is my lowercase r? How do you know the size of the smaller circle? Because remember, I'm only rotating the part that is in blue. Okay, the part that is in blue is the only thing that I'm rotating. At the end, I want my washer to look something like this. I only want this to be defined. I want to go ahead and take away the inside. And where is it hollow? Where is it hollow? It's hollow from the axis of rotation to the x-axis. So it's hollow here, okay? So it's hollow from the axis of rotation, which is y equal to -2, to my x-axis, which is this. So that is 2, okay? So it's hollow from this y -2 to here. So the distance is 2. So my r is 2. And I went ahead and drew a picture here so that you can see it clear of what's going on. So what I want at the end, what I want is only this part to be defined. I'm going to take away the inside. The last thing that I want to do is now, well, how do you find the volume of this? The way that you find the volume is always going to be pi capital R squared minus the smaller circle, which is lowercase r squared and then dx. And then this is from 0 to 2 because it's being stacked on the x-axis. Okay, it's being stacked on the x-axis. Now we replace everything. So this is going to be from 0 to pi x squared plus 3 squared minus pi 2 squared. And let's actually color code it. So 2 squared and this is going to be red. Oh, no. Is there anyone who has any questions so far? Anyone have any questions? Okay, so I'm not going to go ahead and complete the integral. I do want you to practice doing this with the pi. So your answer at the end, I want it in terms of pi, okay? So you're going to have to take the antiderivative. So if you want, I'll give you the final simplified form before you take the antiderivative. This is going to be x to the 4th plus 6x squared, and then 9 minus 4. 9 minus 4, that's 5, so plus 5, and then dx. So take the antiderivative and then substitute 0 and 2, and that should give you your answer. Before I move on to question number 2, is there anyone who would like me to answer a question? Okay, so I'll go ahead and show you a method where you can do this faster without having to draw all the different diagrams. I do like that to draw diagrams because it helps me visualize what's going on. But again, I'm not going to require you to draw all of them. I will require you to have at least the basic sketch, the 2D one. So let's go ahead and do that. And then so you can see a clear example. Uh-oh. Okay, I want to move the whole thing. Okay, that's enough. Okay, number 2 is y equal to 2x and y equal to x squared. And the axis of rotation, y equal to -1. Okay, y equal to 2x, that's just going to be a line. And let's actually put it this one. Uh-oh. Okay, actually, let me move it a little bit more. Oh my God, trying to move it, guys, sorry, but it's not moving. There. Somewhere around there. Okay, and then the next one is going to be y equal to x squared. So x squared, that's going to be this, and then 1, 1, and then 2, 4, which is right here. Try it again. Okay, something like that. And we have y equal to -1 as my axis of rotation. And let's color that a different color. Purple. I want. Okay, so for this one, I'm not going to use the 3D diagram. I'm only going to use a 2D diagram. And then at the end, I'm going to give a 3D sketch. So let's go ahead and find my capital R. So let's make my sample larger disk here. So what would be my R? What would be my R in terms of f of x? What is my R in terms of f of x? f of x plus 1 is correct, right? So f of x plus 1, which is correct. Someone already gave it to us. They're saying that f of x is 2x, so then this has to be 2x plus 1. Okay, now I need to figure out what I'm going to subtract. Well, first of all, I need to know what is it that is being rotated. So what's being rotated is this part. Okay, so that's what's being rotated. So I'm going to subtract from it a disk that has the radius of the green part. So now what is R? What is R? Try to think, what is R? And give it to me in terms of f of x. Yeah, it's still f of x plus 1, right? But we have a different f. And thank you for that. We can actually call this one g if you guys want. So we can call it g. If you don't want to call it f, that's fine. So we now know that this should be g of x plus 1. So therefore, my r is going to be x squared plus 1. Is there anyone who would like me to explain what I have so far? No, we're good. Okay, so these are the two that I'm going to use. So now we write our formula. Remember the formula for the disk, because essentially what we have, and this is where you draw your sample disk. So I'm going to draw something like this. I'm going to draw it here on the side. And then essentially in the inside, something like this. Right? And I'm just going to make a brief sketch here. That's obviously not to scale. But this one is basically x squared. And this one's going to be my 2x, right? So those are the functions, basically. I'm just defining the functions. And what I'm doing is I'm subtracting the larger minus the smaller. Now, if this is confusing you, you can also put it as R. So you can make this one R, the larger one, and then the smaller one is going to be your lowercase r, just so that you know which one is which. And then this is going to be from where to where. So from where to where should I integrate? From what value to what value should I integrate? Yep, 0 to 2. And then always remember this is pi capital R squared minus pi lowercase r squared dx. From 0 to 2, pi, and then capital R is 2x plus 1. It's going to be from 0 to 2, and it's going to be pi 4x squared plus 4x plus 1 minus pi x to the fourth plus 2x squared plus 1, and then dx. Okay. Right. Is there anyone who would like me to explain something? Maybe that's not making sense, that you feel you need more clarification on? Okay, the question is, how do you know which function you use for capital R and for lowercase r? It's based on which one's on top. So which one is on top right here? Is it the line or is it the parabola? Well, the one that's on top is the line. So I have to use 2x. Okay, I have to use 2x. And then 2x is the distance from the x-axis to the function. And then I need to add one more because I still have an extra step. Okay, so you determine based on the graph that you drew. And then the one in the bottom, it was x squared. So that's why I'm using x squared. So x squared, that's going to be my g of x, and then I'm adding 1 to it. Okay. So make sure you differentiate which one's your capital R, which one's your lowercase r. So the red one that I'm using, that's my capital R. And that one's touching my 2x. Remember, this is my 2x. And then the one in the bottom is my x squared. Any other questions? Good question. Someone asked, do you have to solve it or can you use the calculator? You can use the calculator to check your work, but I want the answer in terms of pi. So you do have to take the antiderivative. Okay, someone else asked why on the answer sheet is the answer, well, the setup is different. Well, on the answer sheet, so to finish this problem, first of all, you go ahead and combine like terms, and then you take the antiderivative, right? So I'm just going to put here, you have to continue it. And then let's, on your answer sheet, it's going to have that. And let's just put it here, actually. So this is equivalent to integral from 0 to 2. And then you have the pi on the outside. And then you have 2x plus 1 squared. And then minus x squared plus 1 squared. Okay, so on your answer sheet, you're going to see something like that because they took the pi out. Okay, but like I said, one thing that you want to make sure that you're keeping track of is where the square is at. Don't assume that you can just go ahead and take the square and put it on the outside. That's not what you're doing. You're doing the area of the larger circle minus the area of the smaller circle. The area of the larger circle has an r that is equal to this. The area of the smaller circle has an r that is equal to this one. So there's just different ways to write it. And that's pretty much it. Okay, guys. So go ahead and take a 5-minute break while I make your breakout rooms. Come back at 1:41. By 1:41, I should have your breakout rooms open. And then if you have questions, go ahead and ask me now or ask me when I send you guys into the break rooms, or come back to the main room or come into the room. Either one's fine. No, Nicholas, so I put it here on top. So do 1 through 10, and then chapter 15 is going to be due Sunday. You should start on chapter 15, but you still have time. So either one. And then on Thursday, I will give you a shorter assignment, an even shorter one. So for regular class, you do have to do all problems. For AP is 1 through 10.